All right, so I think I'm recording. Let's take a look at this problem. It's a uniform motion problem. We have two trains are 150 miles apart heading towards each other, but on separate parallel tracks. So we're not going to have a head-on collision. Um, they leave their respective stations at the same time. Train A is traveling at 55 miles per hour, train B at 65 miles per hour. How long after departing will the trains pass each other? About how far will each train travel before they pass? So there's two questions to this problem that we want to answer. So first, just to understand the problems, I need to set up a picture. Um, so I have this train, and you may laugh at my sketch for a train, but this is my train. All right, and I'm going to call this train Train A. You can give it any name that you'd like. Oh no, they did label the trains for us, so maybe we should stick with Train A and Train B. So the rate of Train A is given as 55 miles per hour, and so let's come over here and draw our picture of our other train. All right, train B. And train B has a rate that is faster, 65 miles per hour. All right, so it's leaving here. This one's leaving here. All right, they're telling us that the distance between these two trains at the very beginning before this all starts, so it's really the distance, if we think of the train stations or wherever they're starting from. Now, it wants to know um, this point in time, this point where they meet each other or they pass each other because they're on parallel tracks. The train that's traveling faster will have traveled a further distance than this other train. So um, let's let the distance of train A be x. Then the distance of this other train, it has to make up the rest of the 150 miles because it said they're 150 miles away from each other. So the distance that B travels is the remaining part of the 150-mile trek. All right, and that's in miles. Now, we don't know the length of time that the trains have been traveling, but we do know that they started at the same time and they're going to pass each other. Say they've been traveling on the tracks for the same length of time. So let's do that. Let's set up that the length of time that train A, and now this T is time, not train, is the same length of time that train B has been traveling. And since the relationship distance is equal to rate times time, means that time is distance divided by rate, that same equation. So I can take the distance of train A divided by the rate of train A. That ratio is the same ratio as the distance that train B has traveled divided by its rate. So when you have a claim that two ratios are equal to each other, they refer to that equation as a proportion. And one technique to solve for proportions is to cross multiply. And it's been my experience that students like that technique of cross multiplying, so much so that they even sometimes will call things cross multiplying when it's not cross multiplying. All right, well, maybe I should substitute in my values before I do this. All right, so my distance of A is x. The rate of A is 55. The distance that B has traveled, train B has traveled, is 150 minus x over the rate of 65. So now if we cross multiply, what do we get? 65 times x along one diagonal, and 55 times the binomial, 150 minus x on the other side. So what is 55 times 150? Well, I'm going to have to grab my calculator because I don't know. 8,250 minus 55x. Let's add 55x to both sides. 65 plus 55 is 120. So I have 120x is equal to this 8250. If I divide by 120, 8250 divided by 120, 68 3/4. I'm just going to call it 68.75. Now, what did x represent? X represented the miles that train A has traveled. Now, let's come back up to the question marks to see how long after departing will the trains pass each other, about how far. So this is the second part. About how far will each train travel before they pass. Well, we know train A is traveling about 68.75 miles, and 150 minus that is 150 minus that 81.25 miles. That's the length that train B has traveled. So this is answering the second question. So let's come over and try to answer the first question. How long? So the length of time. Well, if x is 68.75, then on the left, the distance, I can take this 68.75 divided by 55, and that'll be the length of time that train A has traveled, which is the same, since they started at the same time, the trains have traveled the same length of time. So from my equation right here, the time, that t is not train, that t is for time, is the distance that train A traveled divided by the rate that A was traveling at. Well, we have figured out that the distance that train A traveled was 68.75 miles. And we already knew that it was traveling at a rate of 55 miles per hour. So the units work out here nice. That I've got 68.75 divided by 55, 1.25. So I think that under these conditions, when these two trains leave their respective stations, they will meet each other in 1 1/4 of an hour, 1.25 hours. And in that 1.25 hours, train A has traveled 68.75 miles. And in that same length of time, 1.25 hours, train B, that was traveling faster, has traveled further. It has traveled 81.25 miles. So everything seems reasonable, and we've answered both questions. So I think that's all we need to do. Hopefully this helps, and I will talk to you later. Bye.